So, congratulations to you. You've landed your dream job, money manager in a huge hedge fund. It won't be long until you have a place in the Hamptons and, of course, something nice in Provence. There's a very important investment principle that says with proper diversification of assets, a portfolio can have both increased returns and reduced risk. While this may be counterintuitive, it is the strategy of any number of investment programs. So how is a Chi-Sqaure distribution going to help you get that big year-end bonus? Risk is variance, and variance is risk. If all your investment options had the same return, you would have no risk. The variance among the options is zero. Thus far, our interest has been exclusively on the population parameter mu or its counterpart in the binomial p. Surely the mean of a population is the most critical piece of information to have. But in some cases, we are interested in the variability of the outcomes in some distribution. In almost all production processes, quality is measured not by how closely the machine matches the design goal, but also the variability of the outcomes. If one were filling bags with potato chips, not only would there be interest in the average weight of the bag, but also how much variation there is in the weights. No one wants to be assured that the average weight is accurate when their bag has no chips in it. Electricity voltage may meet some average level, but great variability, or spikes, can cause serious damage to electrical machines, especially computers. I would like to have not only high mean grades in my classes, but also low variation about this mean. In short, statistical tests concerning the variance of a distribution have great value and many applications. So let's say you have an investment portfolio inherited from the last person to hold your current position. Don't be too curious about where he is now. Your goal is to reconfigure the portfolio to reduce risk to a target level. You need a test of a variance. The test statistic is the calculated chi-squared equal to n minus 1 times the sample standard deviation squared, that is to say the sample variance, divided by the hypothesized variance. This test will have degrees of freedom of n minus 1, where n is the sample size. With the null and alternative hypotheses, we can now test for our variance. The null is that the population variance is equal to the hypothesized variance, sigma squared naught, versus that it is not equal to this value. Of course, the question may be a one-tailed test, as it seems is your investment portfolio question. You have sampled your portfolio of 30 holdings during the last year. The sample variance you have calculated is 0.15, a pretty volatile portfolio. You would like to test the hypothesis that your portfolio is acceptable to your firm. Your firm has a generally conservative strategy of investment and does not like any of its funds to have a variance of more than 0.10. The null hypothesis is that sigma squared naught is equal to 0.10, and the alternative is that it is greater than 0.10. This is a one-tailed test because if it is less than 0.10, you do not have to take any action regardless of how low it is. Only if the null hypothesis cannot be accepted do you take action, which is to reconfigure your portfolio by making stock trades to reduce volatility. We begin again by setting out the null and alternative hypothesis formally. Then we draw the graph of the chi-squared distribution and marking the confidence level and alpha level. Because we are testing only if the variance is too high, all the alpha value is in the left-hand tail. We now look up the chi-squared value that sets the critical value, the boundary for acceptance and failure of the null hypothesis. Looking at the chi-squared table at 29 degrees of freedom and 0.05 column, we find 42.2 as the critical value. Calculating the test statistic, we find the chi-squared value is 43.5 and is in the tail. We cannot accept the null hypothesis that your standard deviation is within the firm's standard of 0.10. Your conclusion is clear. Sell, 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 and buy government bonds to get your volatility down, or you'll have to quickly adjust your hope.